Hi everyone, so today we're going to learn how to graph a quadratic when it is in standard form. And standard form of a quadratic is the form, I'm just going to write it up here, ax squared plus bx plus c. So we have already learned how to graph from factored form. Now we're going to learn how to graph from standard form. So we're going to talk about two different strategies, and we will clearly tell you when you should be using either of the two strategies. So the two strategies that we're going to talk about, the first strategy is that we will factor first, and we've actually already talked about this. So factoring should be a little bit of review. And that will only work, obviously, if the standard form quadratic can be factored. Not all quadratics can be factored. The second way that we're going to learn how to graph standard form is by completing the square. And that's the method that we talked about last class. And so to complete the square, what we're going to do, or what it's going to accomplish, is it's actually going to convert from standard form into a different form called vertex form. And if we're in vertex form, you'll notice when we do that example, we're going to graph just like we graphed in our previous unit, which is by translating the function left or right or up or down. So we will review those two strategies today. So again, the first strategy is to graph standard form by factoring, and this should be a bit of review. So here's our example. F of x equals x squared minus 8x plus 12. And you may have learned multiple strategies for factoring, so whatever strategy gets you to your final answer, we're ideally looking for two numbers that multiply to get positive 12, and when we add them, we get negative 8. So I'm going to factor this. We've had a lot of practice already factoring, and the factored form of this should be f of x equals x minus 6 times x minus 2. And now that it's in factored form, this should be a little bit of review. We know that these two factors, it's easy for us to say, okay, I can take one factor, x minus 6, and set it equal to 0. And if I solve that, and you may be able to do this in your head, but if I solve that, I will get x equals 6. And that tells me that if I input the value of 6, I will get an output of 0. So it tells me one of the zeros of my quadratic. Then I'm going to go to the next factor, x minus 2. And if I set x minus 2 equal to the output of 0 and solve, I will get x equals 2, which tells me that if I input the x value of 2, I will get an output of 0. So we have 2 points to plot on our graph. So I'm going to plot 6, 0 and 2, 0. And then the next thing that we do, we know that every quadratic should have the same shape. So I know that these 2 points should have symmetry. So I can count the spaces in between them, 1, 2, 3, 4, and I can cut that in half to 2. And I know that my axis of symmetry should be right through the middle. And I'm going to label that axis of symmetry at the x value that it crosses, which is 4 right here. So I labeled it x equals 4. And now what I need to do is find out where the vertex is. It's somewhere along this axis of symmetry. So I'm going to take that value of 4 and I'm going to plug it into my original equation. So I'm going to essentially do f of 4. I'm going to plug in the value of 4. And I like to plug it into my already factored form, which is right here. You could plug it into either, but I'm going to plug it into the factored form. So I get 4 minus 6 times 4 minus 2. 4 minus 6 is negative 2. 4 minus 2 is positive 2. Negative 2 times positive 2 is negative 4. This means that when I plug in the value of positive 4, I get out negative 4, which means the point 4, negative 4 is on my graph. So 4, negative 4 is right here. And really 3 points is plenty to get the general shape of your graph. So you could connect these points. And there's your quadratic. It opens up. We know the vertex is at 4, negative 4. We have 2 other points. It has symmetry. We are done. Okay, so next we're going to use another strategy to graph standard form, so a different strategy. So the directions for this one say graph standard form by completing the square. Completing the square is the skill we learned in our previous class. So to complete the square, we want to take this quadratic in standard form and we want it to be a perfect square polynomial. And a perfect square polynomial means that this middle term, -6, if I were to take half of that term, it would be -3. If I were to then square -3, I would get +9. So to make this a perfect square polynomial, I have to complete the square using that number 9. So we can see that right now, the third term is a +5. That's the wrong term. So we have to get our 9 in there. So how I'm going to do that is I'm going to say, okay, well, I'm going to add 9 because +9 is the number that I want. And then I know that if I add 9, at the end of my equation, I also have to subtract 9 so that those will balance each other out. So now I'm ready to condense my equation. So I can see x squared minus 6x plus 9, that is ready to be written as x minus 3 squared. And then my last two numbers, +5 minus 9, if I combine those, I get -4. So I've completed the square, and now my function is written in a different form. This is actually called vertex form. And you may not realize it, but we already know how to graph this form, pretty much. So we know we can identify from our previous unit on family of functions, I can identify, since this has this key feature of an exponent of 2, that this is a quadratic. So I know that this should look like a U shape, and it should be opening upwards because there's no negative out front. And I also know that these two numbers, the -3 is inside the parentheses, the -4 is outside the parentheses. I know that that -3 actually means right 3, and the -4 outside means down 4, which means that our key point in our parabola or our graph of our function should be right from the origin, should be right 3, so right 3, and then down 4. So I am going to plot a point right 3, down 4 from the origin, and there is my vertex. So I'm going to write underneath here that the vertex, or my key point, is right 3, which is +3, down 4, which is -4. So there's my vertex. So we already know in general, we know our vertex is here. We know our graph should look something like this. It should be opening up and be a U shape. But really, to get an accurate graph, we need at least 2 more points, one to the left and one to the right of this vertex, to know what points our graph goes through. And to do that, we're just going to choose another x value and plug it in. And really, you can choose any x value that you want, but in general, what I like to do is, we know that our vertex is the middle of our graph. So we actually know that there's like this dotted line through the middle, our axis of symmetry, right, that goes right through the middle. So I like to pick a point close to the axis of symmetry. So my vertex is right here at 3, -4. I'm just going to go one value to the right. That would be the value of +4 on the x-axis, and I'm going to plug in +4. So I'm just going to write here, plug in another x value, and I'm going to choose the value +4. And really, you can plug in any x value that you want. I'm choosing 4 just because it's close to my axis of symmetry. And f of 4, if I plug it in, you could plug it into either form, the original standard form or the vertex form. I'm going to plug it into the vertex form. 4 minus 3 squared minus 4. 4 minus 3 is 1 squared minus 4. 1 squared is 1 minus 4, and I get -3. So 4, -3 is a point on my graph. So I'm going to plot 4, -3. Now, with quadratics, we know that they're symmetric. So if 4, -3 is on my graph, then a reflection of 4, -3, so this is one value away from my axis of symmetry, one value in the other direction, there will be another point. So there's my third point. And that is enough to graph. You have 3 points. But if you wanted to plug in another x value, you certainly could. I'm just going to do another one just for the heck of it. So I'm going to plug in 5, f of 5. And when I plug in 5, I get 5 minus 3 squared minus 4. 5 minus 3 is 2 squared minus 4. 2 squared is 4 minus 4, which is 0. So I know that the point, when I input 5, output 0. So I can plug 5, 0 right there. And then that is 2 values away from the axis of symmetry. 2 in the other direction would be right there. And that is enough for me to connect my points and make my parabola. All right, so we have graphed using completing the square. Again, just to review the steps, we completed the square in order to get ourselves into vertex form. We used vertex form to find our translations, right 3, down 4. That gave us our vertex, our central point. And then we just had to pick an x value around that vertex to plug in. And again, I chose 2, but it would be sufficient to just choose 1. That would get you 3 points total. All right, now we're going to practice this. Good luck.